Okay, we continue on our synchronous class, and then LP4, that is nucleic acids. Some ribonucleoside, deoxyribonucleoside, when the sugar is a beta D-ribose. So again, that beta thing has something to do with your arrangement. When the sugar is being made from your open chain sugar. So I think in terms of drawing, the beta type is um, your beta D ribose, your D ribose first, that is a dextrorotatory ribose, is drawn the is drawn of the upper part. When the sugar is a beta, the resulting compound is a ribonucleoside. You can see that the drawing there, in terms of projection from your Fisher projection, that the that group that group is on the upper side. Maybe we can look at figure 9.3. Figure 9.3, we just go back. So 9.3, there you go. That is being beta. This number one here, as you form your ribose from your sugar, as that sugar is, this is the number one. And from your number one, so this is somewhat similar to your Fisher projection, wherein, or probably from your, what do you call this, the um, uh, Hammond, Hammond projection, that the looking at for a ring type. So you usually looking at the uh, being flat, or maybe you're just looking at it flat, but of course it has a different, probably different scenario in terms of a real draw. I mean, in a 3D application or in its reality. How does it? We only have to see this as how we view them, so that we are on one page with the chemists, okay, or the biochemist. So for the beta type, your this pyrimidine basis, nitrogenous uh, basis, is located at the top. Okay, I think it's something to do with the arrangement on how you also view your DNA or your RNA. If it is viewed which is on the top or which is down, so that you would be in one page. So that whenever the biochemist or the chemist will be telling chemical reactions or what is happening because of this, so you are on the same page. So the beta again is telling us that um, the thing, just like this one, the nucleus or the nitrogenous bases are on the top side. The other one actually is an alpha type. I think we've already discussed it in proteins. So the alpha and the beta. So just go back there if you cannot understand them. Okay? So you have a, how do nucleotides combine? So going back to the glycosidic linkage is from C1. See, the carbon is being numbered. So the glycosidic linkage, so that linkage is glyco from the word sugar, sugar linkage. From the sugar linkage is from carbon 1 of the sugar through the nitrogen 1 of the pyrimidines. So that nitrogenous basis. So from nitrogen 1, from organic chemistry, that's why I wanted to include the nomenclature, really, because that's where you can understand what are the scientists is telling us about what nitrogen, what carbon are they talking about. So that's the importance of it, so that we can recognize. Because if we cannot recognize, of course, we will not be would not be understanding if they're highlighting the part of the molecule that has something to do with a particular concept. Okay, so you can see that the glycosidic linkage is from C1, that is the carbon number 1 if you're numbering your ribose, and your nitrogen 1 if you are numbering your pyrimidines, logically from your nomenclature of organic chemistry, or to the N9. So it could be the N1 or the N9 of your nitrogen of purines. So pyrimidines or purines again contains that nitrogen bonded to that sugar, making that ribonucleoside or the deoxyribonucleoside. When phosphoric acid is esterified to one of the hydroxyl group, the sugar portion of a nucleoside, nucleotide is formed. So when a phosphoric acid is esterified, so again that word esterified is a chemical reaction which involves with esters. So you have to again to look at the, I think it contains an oxygen. Oxygen ethers, oxygen double bond to carbon, esters, I think it's a carbonyl part. So we only have to, even I cannot memorize, but of course, if I want to dig deep, I meaning there's something that I do not understand, I only have, that is more on the chemistry part, I mean the organic chemistry part, then um, I sure know how to look properly for that particular information. So anyway, that's the only information that is given here. The chemistry part, of course, it is laid aside to the organic chemistry. Nucleotide is named for the parent nucleoside. It's about for naming. And then I highlighted also the 5 prime. So the 5 prime, I think the prime stands for something with the order of your DNA or RNA, how it is read from 3 prime, or how the DNA is being made. There is a portion how a particular RNA makes or builds up your DNA or your RNA. So that is the prime. I think the end, how it is being bonded to one another, has a direction to it. So it has something to do with the 5 prime and 3 prime, as you can see from that discussion. The 5 prime nucleotides, so meaning on the other end, because there's only a 3 prime and a 5 prime end, the 5 prime end nucleotides are most commonly encountered in nature. See? So it is common in nature. So the nucleotides not in the 5 prime, maybe there are, but it is not encountered in nature. So we have to pay attention to it because that's how nature are built. Or we, again, nature is still the best manufacturer of things, not the humans. See, we can manufacture things but not efficiently. What are the things? There are a lot of things we miss. Unlike how the nature works, we only have to study them so that we can understand or gain wisdom from it, and that's the wisdom of God. So that is being a religious. Anyway, the polymerization of nucleotides. So it means that nucleotides now is being bonded together. So that is the term. The polymerization of nucleotides give rise to nucleic acids. So that those nucleotides are bonded to each other, just like the carbohydrates. You have the monosaccharides building into disaccharides, building into oligosaccharides. You have the amino acids building into um, uh, peptides and polypeptides, meaning proteins. Just like also with your nucleic acids, the DNA and the RNA are somewhat came from the units of nucleotides. So that's what it says. Okay, the link between, anyway, I will be only explaining the the part that I highlighted because that's what I'm, for me that's the myth and everything that I read. Then I highlighted there the 3 comma 5 prime phosphodiester bond. So again, it is talking about the bond on those ends of as it is being built. Okay, so as long as it is finished, you have endings there. So the 3 prime, the 5 prime phosphodiester bond. The nucleotide residues of nucleic acid is numbered from 5 prime end, which normally carries a phosphate group. So normally the 5, so I'm already low bat, and then